In this video, we're solving a second-order differential equation using the method of undetermined coefficients. For this example, we're solving y prime prime minus 2y prime plus 5y equals 0. With the initial conditions, y of 0 equals 0 and y prime of 0 equals 1. First step is to form the characteristic equation. So we assume that we have an exponential solution, y equals e to the kx. From here we have to differentiate, so we get y prime equals k e to the kx, and differentiating again, y prime prime equals k squared e to the kx. We can substitute these three equations into our differential equation, and this gives us k squared e to the kx minus 2k e to the kx plus 5e to the kx equals 0. Since e to the kx is non-zero, we can divide by e to the kx and we get k squared minus 2k plus 5 equals 0. So solving the quadratic equation, since we can't see any obvious factors, we're going to use the quadratic formula. This gives us that k is equal to 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 5 all over 2 times 1. And this simplifies down to 1 plus or minus the square root of minus 4. Therefore, k is equal to 1 plus or minus 2i. So we can use the formula from the table to get the general solution in the case where we've got complex roots. In our case, alpha is equal to 1, beta is equal to 2. Therefore, the general solution is e to the x times a cos 2x plus b sine 2x. So we can now apply the initial conditions. So substituting in that first initial condition, y of 0 equals 0, this means that when x is equal to 0, y is also equal to 0. So placing all of the x's and the y's with 0, we get that e to the 0 times a cos 0 plus b sine 0 equals 0. We know that sine of 0 is 0, so the b sine 0 will vanish. Cos of 0 is 1 and e to the 0 is 1. Therefore, the left-hand side, we're just left with a, so a is equal to 0. So to use the second initial condition, y prime of 0 equals 1, we first need to differentiate the general solution. So differentiating y, using the product rule, we get that y prime is equal to e to the x times a cos 2x plus b sine 2x minus 2a sine 2x plus 2b cos 2x. So the condition tells us when x is equal to 0, y is equal to 1. Therefore, we get that e to the 0 times 0 cos 0 plus b sine 0 minus 0 sine 0 plus 2b cos 0 is equal to 1. So again, we can simplify. E to the 0 is 1. 0 cos 0 is 0. 0 sine 0 is also 0. Sine of 0 is 0, so the b sine 0 will vanish. And this will just leave us with the 2b cos 0. But cos 0 is 1. So we're left with 2b is equal to 1. And therefore b is equal to a half. So having found the values for a and b, we can substitute these back into our general solution, and this gives us the particular solution, y equals a half e to the x sine 2x.